So let's start with question number 4. How can we optimize link relationship using data load options? Now, in our previous question, what we had done is that we had basically loaded one-to-many and many-to-one relationship using link objects from the database. So what we had done is basically we had a customer table. Every customer had multiple addresses and every address had a phone record. And we created 3 classes. The first class was the CLS customer with addresses, which basically mapped to the customer table. The second class is CLS addresses, which mapped to the customer addresses table. And the third class was CLS phone, which mapped to the phone table. Now, in order to define one-to-many relationship between customer and addresses, we used entity set. So we created a generic entity set object of CLS addresses inside the customer class. To define one-to-one relationship between addresses and phone, we created an entity ref generic object of CLS phone. And in this way, we were able to define one-to-one relationship between addresses and phone. Later, we consumed this whole relationship in our LINQ query in the ASP.NET X behind code. Okay. Where we basically we executed the query and we loaded the whole customer object with its phones, with its addresses. We then used the for each to loop through every customer row. We used the for each again to loop through every addresses in the customer object, and then we used the phone object to display the mobile phone and landline. So in this way, we were able to define the complete one-to-many and many-to-one relationship in our link entities, and this worked very much fine. Now, out of curiosity, what we will do is that we will try to see that how basically were the SQL executed at the backend, because we have not written any stored procedure or any SQL statements inside our code, and these all SQL statements are fired from the LINQ framework. So what we'll do is that we'll try to analyze that how were the SQLs fired in order to load these LINQ entity objects. Now, in order to see that how LINQ engine basically fires SQL query for this one-to-many and many-to-one relationship, what we will do is that we will go to tools and we will run the profiler. Now, profiler basically captures events which happen in SQL Server. So let's run a trace, and what we'll do is that we will keep this trace simple by only selecting necessary events, because we are only interested in SQL statements. So we are only interested in stored procedures and TSQL. Currently, we are not interested in audits and sessions. So let's run this trace, and let's go back to our project and we will run our link to SQL relationship entity. Now it has loaded all the records, and you can see that for every customer it has loaded addresses and phones. Addresses and phones. Now let's see what has happened in the profiler. Okay, in the profiler it has shown a lot of SQL statements because currently I have approximately 3,000 records of customers. So you can see that there are a lot of records. But what we'll do is that we'll handpick the first 10 records and try to see that what exactly LINQ engine has done. Okay, let's take up the first statement in the trace. You can see that it has fired one single SQL statement to the customer table. Okay, now for this customer table or for this customer record, it has fired again one single SQL statement to the customer addresses table. So it has taken the customer 1 and fired to the addresses table. Now for this address, it has fired again one single SQL statement to the phone table. So in other words, for every LINQ entity, it is firing one single SQL statement. So in other words, we are going to have a lot of round trips. And when we talk about big projects, let's say that you have 10 or 15 classes, and if you're going to have, let's say, at least 8 or 9 relationships, so we are talking about probably firing for one record or for loading one record in the LINQ. We are talking about firing 8 to 9 SQL statements, and that's pretty not a scalable solution. Okay, so our question was on the same grounds. How can we optimize this round trips or these multiple SQL statements using data load options? So this video is dedicated to improve the link performance from the standpoint of using entity set and entity ref. Now, in order to bring down the number of queries which are fired for every link entity, we can use something called as a data load options. So what LINQ engine tells is that if you can specify me the relationship between your entities beforehand, I can use that knowledge to fire only one SQL statement. Now, in order to specify that relationship knowledge to the LINQ engine, we can use the data load option class. So what I've done over here is that I've created a data load option object. I've then used the load with method to say that yes, there is a relationship between customer and addresses, and there is a relationship between addresses and phone. And then this whole data load option I am passing on to the data context using the load option property. Okay. So now that I've specified saying that which of my entities are having relationships, LINQ engine will use these relationship to load all the data in one go. So now let's do one thing. Let's go and run our profiler. Okay. And let's go and run LINQ to SQL using data load options. And let's see what happens in the profiler. Now in the profiler, you can see that it has fired only one SQL statement. And this one SQL statement loads your customer data, your customer addresses data, and your customer phone data. So in other words, it had just fired one SQL statement, and that's a remarkable improvement over the previous trace where we had 3000 SQL statement been fired. At this moment, I have 3000 records in my tables. So it has fired 3000 into 2 because I have two relationships. One is between customer and customer addresses, and one is between addresses and phone. So it has fired approximately 3000 into 2, that is 6000 SQL statements. And by specifying data load option, it has fired only one SQL statement. So by using data load options, you can really improve your performance. One of the important points to remember while learning new technologies is just not to learn new technologies, but to really know how to use these technologies in a very efficient manner in your project. So I hope that this session was useful, and in the coming up sessions, we will be looking into more such kind of performance improvement methodologies in LINQ to SQL, which you can really use effectively in your project.